Hi everyone, in the last lecture we learnt about the definition of Poka-Yoke. We looked at the standards for a good Poka-Yoke inspection device, and we looked at some examples of Poka-Yoke in our everyday lives. And so in this lecture we're going to look at some of the cognitive science behind Poka-Yoke and human error. So the learning objectives for this lecture are to understand Poka-Yoke in the broader context of cognitive science and human error, distinguish types of human error, and incorporate knowledge of human error into Poka-Yoke. So, as I said last time, there's been very thorough research in cognitive science on types of human error. And a couple of books I'd really recommend reading is The Design of Everyday Things by Don Norman, and also Human Error by James Reason, although this is a bit more drier and technical. And these are two cognitive scientists who have done a lot of research into how and why human error occurs. So as Don Norman would say in his book, human error is a result of bad design, not people. And this again ties to the idea in lean production that we blame the process, not the person, when error and defects occur. And by understanding the type of error, this can help us design better Poka-Yoke devices. So here's an algorithm developed by James Reason into identifying the type of human error. So first, we have to consider, when we take an action, was there a goal or plan in mind? And if not, was the action that resulted intentional? So if we do something erroneously, then this is an involuntary action. And if we do something without really having a goal in mind, this is a spontaneous action. So what if we have a goal in mind? So we intend to do something, but then the actions don't proceed as planned. This is known as a slip. Okay, so then we have the situation where we have a goal in mind and we carry out the action as planned, but then the actions don't achieve the goal we originally intended. And this is known as a mistake. And if we have a goal in mind and everything proceeds as planned, then there's no problem. So an error occurs when there is a difference between an intended outcome and our actual outcome. So when we have a goal in mind, but then we don't achieve that goal. So you'll see that there's a few actions in there that don't constitute human error. So the first lot of problems are unintended actions. So these aren't errors because there is no disconnect between intention and outcome. But nevertheless, they're still a problem, and how can we address them? Well, in the last lecture, I talked about using setting or forcing functions to constrain the action. And this involves contact type devices, so we detect a defect through physical abnormalities such as shape, weight, or color. A fixed value, that is, we constrain the number of actions taken, or we use motion steps, so we constrain the sequence of actions that a person can take so that no erroneous actions can occur. So Don Norman and James Reason categorize different types of human error. And remember, an error is when there is a difference between our intended action or goal and the outcome. So the first of these was slips, when the intended action does not match the goal we originally started with. And then mistakes occur when the goal did not achieve what we planned. And so there's something wrong with the original formulation of the goal in mind. So with slips, we have capture slips, and this is when a more frequently performed activity is carried out than the one intended, or when we go into autopilot. So our brain switches off and we kind of just do something we're used to doing rather than what we should be doing in that moment. Then we have description similarity. So the correct action is executed on the wrong target. And then a mode error. So this mostly occurs with electronic devices, and this happens when the controls on the device are confusing and we don't know what system state we're in. So mistakes are a bit more rare, and they involve usually highly trained or skilled activity. And so most types of human error are not going to fall under this category, but nevertheless it's interesting to learn and understand. So within this we have a rule-based mistake, when we apply faulty rules or incorrect evaluation of a skilled activity. A knowledge-based mistake, so insufficient skills or knowledge for a novel situation. So obviously with Poka-Yoke, because the situation is new and unexpected, it's going to be hard to create a sort of Poka-Yoke device that can address this. And then lastly, we have a memory lapse. So the goal or plan of action is forgotten, and this is commonly caused by interruptions. So this is probably something we might experience in our work processes. So how do we address slips? Remember that a slip is a difference between what we intend to do and what we actually do. And so capture slips happen when our brain slips into autopilot, and we can address this by avoiding procedures that start off identically then diverge. With description similarity, we have to make sure that controls and displays must look and feel different, and we can achieve this by using things like visual management. And then we have mode error for electronic devices, and we have to address this by making the current system state continuously available, or not having more actions than control inputs. Lastly, addressing mistakes. Rule-based mistakes. So there's a problem with the rules that we apply for carrying out a task. Basically, use more guidance in information, or use visual management. Knowledge-based mistakes. We need good procedures and instructions, and with memory lapses, we can use visual management to track the current state or progress. We can use flowcharts so that people can track where they are in the procedure, or we can use checklists. So let's go and look at some examples. Look at this clock. What time is it? You may want to pause the video and give yourself some time to try and figure it out. It's very difficult, and the problem we have here is a rule-based or knowledge-based error from an unusual clock arrangement. So having standardized clocks makes the time easier to read for everyone. So with our procedures and tasks, we should use a standardized layout. And the purpose of this is that we reduce mirror or inconsistency with how the task is carried out. We reduce muri, or the burden of learning the task and figuring it out each time we do it. And we reduce muda, or the wasted time trying to relearn and perform the task. Next, stove controls. So many of you probably experienced this. Have a look at this picture. Which switch matches which hot plate? It's not obvious. And what we have here is a problem with description similarity, in that all the controls look the same. And what we should do is rearrange the spatial layout of our controls and the hot plates themselves. And this is the idea of using visual management to mitigate error. So we looked at Poka-Yoke. What is Poka-Yoke? It is an error-proofing device. We looked at the definition of a good Poka-Yoke device, and we also looked at examples of Poka-Yoke, and then now we've looked at human error in cognitive science and how that can help us in a few examples. And this can help us reducing waste in our processes through defects.